Today we're going to convert between polar coordinates and Cartesian coordinates. Before we get started with that, I'd like to introduce you to some of the basic graphs involving polar coordinates. First one would be a graph where r equals 2. And so you can see on here that r equals 2 anytime we are on the second circle from the center. So I'm going to highlight that for us. This would be the graph, r equals 2. In other words, the angle could be any angle. It's a little hard to trace. Pretty hard to trace the little tablet that I'm using attached to the computer. Next, theta equals pi over 4 could have any radius, it just needs the angle pi over 4. Now remember that pi over 4 is 45 degrees. So 45 degrees would be this line here. And so we'll trace that out. We can go in both directions from there. So remember, the radius could be positive on this upper right-hand part, or the radius could be negative, and if the radius was negative, then we'd flip it across to the other side of the origin there. Now, in order to convert from Cartesian equations, the ones that we're used to, into polar equations, we want to use three facts. The first one is that x equals r cosine theta. Now, x equals r cosine theta is one that was introduced in our last lesson. The other one, just want you to write it down again, is that y equals r times the sine of theta, and that x squared plus y squared equals r squared. So our goal is to get an equation that looks like r equals, and it's going to be r equals, and it's probably going to have some signs and or cosines involved. So our first example, x squared plus y squared equals 6y. So first thing I'm going to notice is that x squared plus y squared equals r squared. So I'm going to write that r squared in on the left side. Next, 6y, this y, we could substitute r sine theta in place of the y, so let's do that. Now we want to get this into the form of r equals something. Now I've got an r squared on the left, and I've got a 6 times r times sine theta on the right. So what I see is I've got a common factor of at least one r on both sides. So if I were to divide both sides by r, whoops, don't like that. Sorry about that. If I divide both sides by r, let's get this back. Pause here. Ink just disappeared. Let me pause the video for just a moment. Alrighty, I'm sorry about that delay. I've got the pen back. So if we divide both sides by r, we're going to be able to divide out an r on top and on the bottom, and then the left side will be r squared divided by r, which is r. On the right side, we've got 6 times the sine of theta. So we've gotten that format of r equals, and then we might have sines or cosines, and in this case, we've got a sine over there. Next, y equals 3x plus 2. So I look up there and I see that y equals r times the sine of theta. So let me substitute an r sine of theta there. In place of the x, let's substitute a r times cosine theta. Let's not forget that plus 2 tacked on to the end there. I look over here and I see that I've got an r on the left side and we've got an r on the right side. Now I can't just divide both sides by r like I did last time, because if I did that, we would have to divide the first term by r and also that plus 2 by r. If I did that, I would lose the r in the first term, but I'd end up with a 2 over r in the second term. So I don't really want to do that, so let me erase that. So what we can do, though, is we can pull all of those r's over to the left side and leave that 2 on the right side. Here's what happens when we do that. We're going to have r sine theta minus 3r cosine theta set equal to 2. Now, I've got two terms on the left side. Both of them have an r in it, and so we can factor out an r. It's going to be r times sine theta minus 3 cosine theta equal to 2. Now, I've got an r times this difference over here in parentheses. So if we divide both sides by that set of parentheses, we're going to have r by itself, which is exactly what we want. We want r equals some expression. So when I do that, it's going to be r all alone on the left side equals 2 divided by what's in these parentheses. Sine theta minus 3 cosine theta on the bottom. So we can convert from Cartesian to polar equations, and we can also convert the other way, polar equations to Cartesian. So in order to do this, let's remember 3 facts. Earlier this school year, we studied those definitions of the sine, cosine, and tangent. We could define sine of theta as opposite over hypotenuse, and we can also define it as y over r. So we're going to use that one here. We can define cosine as x over r. And we can define r as the square root of x squared plus y squared. We basically get that from this r squared equals x squared plus y squared up top. Square root both sides, and this is what you get. Now our goal when converting from polar equations to Cartesian equations is to convert everything into x and y's. Now it's a bonus if we can get it in y equals form, like the familiar lines and graphs that we've done in our math past. Another tip that I'd like to offer is sometimes it's good to substitute in for r last, and I'll show you what I mean by that. So this first one is r equals 2 sine theta. Now sine of theta we see as y over r, so that would be 2 times y over r. Now we can multiply this whole number 2 by this fraction on the right side, and that's going to be 2y over r equals r. Now this r is in the denominator, so what I'm going to do is I'm going to multiply both sides by r, and that's going to undo that divide by r on the right side. So then we'll have r squared on the left equals 2y. Now we can use this r equals the square root of x squared plus y squared fact, and when we do that we're going to have parentheses the square root of x squared plus y squared squared equals 2y. Then the squared and the square root will undo each other, and we're going to have x squared plus y squared equals 2y. And we can leave it like this. I mentioned that sometimes it's helpful to get y by itself, but since we've got a y squared and a y, we're just going to leave it like this at this point. So this would be good enough. We've just got x's and y's. Next one. First thing I'm going to do is I'm going to take that cosine theta and I'm going to substitute x over r in its place. So when we do that, we'll have 3 on top and 1 minus 2 times x over r. I'm going to multiply that 2 times x over r together, and we'll have 1 minus 2x over r. Now we've got a pretty messy denominator there, and if we can get common denominators between that 1 and this 2x over r, we can subtract those two fractions, and it's going to simplify things a lot. So I'm going to change that 1 into an r over r. By doing that, we'll have common denominators now. R over r. With common denominators, we can subtract that r and 2x, leaving us with the new combined denominator of r. Next, what I'm going to do is I'm going to keep, change, flip. Keep the 3, change, divide to multiply, and then flip that bottom fraction. So keep 3, multiply by flipped form of the fraction. Three times r up top is 3r, and then 1 times r minus 2x looks like this. Now it's still a little messy, but here's where we can go from here. We've still got a bunch of r's in this situation. I don't want to substitute square roots of x squared plus y squared in here yet. I'd like to combine the r's in some way if possible. So here's what we'll do. I'm going to undo this dividing by multiplying by r minus 2x on both sides. R minus 2x. So when I do that, these cancel out, and I'm left with 3r on the right. Then I use distributive property and get r squared minus 2. Well, actually, rather than distributing, I'm going to just leave that as r times r minus 2x. The reason I'm going to do that is because now I've got a factor of r on the left side and a factor of r on the right side. So if we divide both sides by r, we're going to have r minus 2x equals 3. Then we can substitute in place of that single r that we've got, because r equals the square root of x squared plus y squared minus 2x equals 3. And at this point, we've got just x's and y's, and we're going to keep it like it is for now. Last, I'd like to give you a brief introduction to what some of these polar coordinate graphs look like. First off, r equals 4 cosine theta. Remember that cosine is related to the x variable from our equations in the past. And so turns out that the graph of r equals 4 cosine theta is going to be a circle with a diameter of 4 that touches the origin over here. Now, this 4 represents the diameter of the circle, and if this number were negative, then it would be a circle, but it would be on the left side of the graph. A same size circle, but over on the left. R equals 3 sine theta is going to be something like it, but since sine is related to y, it's going to be a circle with a diameter of 3.